And keep in mind, so then sometimes now the concept that we are going to discuss is not only valid like this, so it is also valid for like water or any other liquid as well, right? Now, air resistance or the water resistance or the drag resistance means now we know about the friction, right? Now, when an object is moved against a surface like this, so when this one is pulled towards right hand direction, so then there will be a force acting opposite to it towards the left. So then that is what we call as the friction. Then similar to that, when something is moving in a specific direction like this, there is always opposite force acting in the other direction due to the air. Right now, when even when we are walking, right? So if you are walking to forward, so then there will be a resistive force due to the air particles acting backwards, right? Now this is caused by like this. Now when the object is trying to move forward, right? So what will happen is the air particles will move and collide with your body, right? Whatever the air particles are moving and colliding with your body, so then as a result what will happen, so then we know if some object comes and collides with your body, you can feel a pain. So then because of the object collision of the object exerts a force on your body, so similar to that, so then these air particles, right, so they will exert, it could be a very small value from one particles, but overall when there are a lot of air particles collide with your body, so there is overall a resultant force acting backward, right? We discussed about resultant forces before. So similar to that, there will be a resultant force acting backward. So then that force is what we call as the air resistance. Another name we use for that one is the drag force. Is it clear? Now think, now you are swimming, right? So think you are swimming. So then uh, is it easy to swimming compared to walking in air, right? So but if you try to walk in the water surface, right, so you have whether swimming or trying to walk in the water, it is much difficult, isn't it? Yeah, so why is that? When you are moving forward, right, so when we are trying to move forward, what will happen is, right, so now we know everywhere we have air particles, right? So when we move forward, what will happen, we our body will be colliding with these air particles, right? So every time they collide, every time these air particles, it is not just one or two like this, there are billions of air particles if you consider small space. So then those air particles will be colliding with our body as we move forward. Same thing will happen if you try to swim, right? So in the water, right, when you are swimming, right, so then what will happen, those water particles or the liquid particle, right, so they will always collide against your body, isn't it? Right. So when those things are colliding with your body, what will happen is they will exert a force, right? Now for example, if we hit an object to if we hit your body with an object, let's say maybe a rubber ball, right, so you will feel a small pain, right? So why is that? Because every time this ball collides with your body, it exerts a force, right? So similar to that, every time these water particles or these air particles collide with your body, so they will be exerting forces on your body, right? So then their force, that force, the resultant force, the total force of that entire resultant force of the forces exerted by each particle, we can call it as the air resistance. Understood? Is it clear? Yeah. So then now we know if you are not moving at all, right, let's say you in the water, right, you just sink in the water, right, so neck above, right, so you're just sitting like standing like that, right, in the water. So then the water is also not moving. If the water is also not moving, so then the water particles are not colliding with your body. So then if you are not moving, if you are not moving, there will be no water resistance or air resistance, right? So no motion, then no air resistance, right? So this is just like friction, right? So normally the friction is acting also if object is starting to move or if it is trying to move. But if you are not trying to move or you are not actually moving at all, so then there will be no frictional forces or no air resistance acting on your body. Okay, right. So then tell me now, let's say you go to the beach, or a lake, or wherever, swimming pool, right? So let's say you try to walk in the water, right? So then what happens, there's a some sort of a shark or something, right? So you are trying to run out of the water, right? So which one is easy, walking out of the water or running out of the water? Walking is easy, if you try to run, what will happen, it gets even difficult, right? So more difficult. So when you try to run in the water, right? So here what is happening is, right, when you are trying to run, what happens, right? So more water particles will be colliding with your body. Okay, so that means if your speed increases, more water particles or more air particles will be colliding with your body. So as a result, what will happen, the air resistance or the water resistance will increase when the speed is increasing. Understood? Right. So every time that means if you are not moving, if the speed is zero, the air resistance acting on your body will be zero, right? But if you start to speed up, so then what will happen, there will be air resistance acting, and that air resistance is also increasing, right? So every time you move through when you're moving, when you're walking, when you're running, right? So even if you are riding a vehicle, right? So then if an object is falling, right? So all the objects, they are generally, when they're falling down, right? So they will, their motion will be controlled by the air resistance, right? So it may looks like it is not a very strong force, but it has a very good uh, impact on the motion of any object in any direction. Okay, is it clear up to this point? Right. So if you go to the note, right? So it says when an object moves in the atmosphere, there will be an air resistance acting on it always. Sometimes we ignore the air resistance, then the fall is similar to falling in the vacuum. When an object is falling without air resistance, it's called free falling. Free falling bodies will have a constant acceleration of g. If the object is moving upward without air resistance, it will have g deceleration, right? Now what is this one is saying is, right, now when an object is falling downwards, right, so what will happen, the weight is acting downwards, right? So while it's moving down, what happens is air resistance will be acting upward, right? Now previously we have discussed, right, so Newton's laws, we discussed F equals ma equation, right? So F means the resultant force. So then if there is larger air resistance acting, the resultant force acting downwards will be lesser. So therefore resultant force is W minus whatever the air resistance value. This one should be equal to mass into acceleration. So then if the air resistance is higher, right, so then acceleration will be lesser. But most of the time when you're doing our calculations, right, so in our school exams or anything, right, so whenever we do the calculation, we don't consider about the air resistance. Normally air resistance is ignored because it makes the calculations and everything complex. Okay, so as a result, what we do is we forget that the air resistance exists, right, and we do whatever the calculation. So then if there is air resistance is not there, the only force acting, now let's say object is falling down. So if an object is falling down, the only force is acting is the weight of the object, right? And last time we discussed the weight of object we can write as mg. So then if we apply F equals ma to this equation, this situation, weight is equal to mg. So mg is equal to mass into acceleration. So then both sides we have mass and mass. So then here we get acceleration is equal to g. Okay, so that means when an object is falling without air resistance, without air resistance means like a vacuum. If there is no air particles, it is, we call it as a vacuum. Vacuum is an empty space, right? So then when an object is falling in a empty space or a vacuum, so then it will be falling with a g acceleration. We discussed g value is 10 meters per second square. Is it clear up to this point? Right. So here in the note, just mention like this. Uh, in this space, just mention when there is no air resistance, what happens? So object is falling downward, so the weight is acting downwards, weight is equal to mg. So if we apply F equals ma to this object, mg is equal to ma, so we get mass to mass cancels out, so then acceleration is equal to g. Right, first part, what is the weight of the object? So we can discuss this one relate from the thing we discussed last time, right? So last week we discussed weight is equal to mg. So then m is 20 kilograms, g value is always 10. So then the weight of the object is coming as 200 newton. State the value of the acceleration of the object, right? So now here, it's not mentioned whether we are considering their resistance or no, right? But since it's asking the value of the acceleration, so we have to assume that there is no air resistance, right? Assuming there is no air resistance, right? So then acceleration is 9.8, or even if you take as 10 meters per second, that's okay. Right, so that assumption you have to say. Normally in calculations they will tell you in a question, for air resistance is negligible, air resistance is ignored, ignore the air resistance, they will tell you like this, or else, right? So normally if you have to consider the air resistance, that will also be mentioned there. So then in this case we can just consider it is air resistance is not there. Right. Next one, calculate the speed of the object after 3 seconds of falling. So then these things we discussed earlier, right? So we can use the definition of the acceleration. Acceleration is equal to v minus u divided by t. So then acceleration when an object is falling, that is equal to 10. 10 equals to final velocity is what we are trying to find out. Initial velocity is 0 because it is dropped from rest. In the question it says the mass is dropped from rest. So then the time taken is 3 seconds. The question says how what is the speed after 3 seconds. So then when you make the v subject there, we will be coming as 30 meters per second. Right. So since we missed this part, just write this one there and keep in mind, right? So we can use those two equations to do any calculations related to the motion. And take few minutes and try. Then we will be discussing this one. Right. I think we can go through this one. So object is thrown vertically upward. Air resistance is negligible. State the magnitude of the deceleration as the object moves up. So then this is also mentioned in the note earlier. Right. Here it says, right. So this third point, right? So when free falling bodies will have constant acceleration of g, if the object is moving upward without air resistance, it will have a g deceleration. So that means this object, when it moves upward, so it has a deceleration of g value. Deceleration means g value means it is 10, right? So then we can, even if you say g is fine, or you can say it is a deceleration. So therefore they are asking, the question only says the state the magnitude. So then the magnitude is 10 meters per second square. But if you consider it as acceleration, then acceleration is minus 10, right? So deceleration values are equal to minus acceleration. We have discussed that one before. right? So then second part, calculate the time taken for the object to reach its maximum height. So we know if an object is thrown vertically upward, what will happen? uh, okay, to do that, actually I didn't give you the speed, no. You need the speed actually, right? So here, so an object is thrown up vertically with initial speed of 40 meters per second, right? So that value I forgot to give you earlier, right? So initial speed of 40, right? So when we know if you throw an object vertically upwards, so then what happens? So it will go up like this. So we know as it goes upward, the speed is decreasing because of the deceleration. So then when the speed becomes zero, it will come to a rest for a particular second. So then what will happen at this point, its weight is acting downward. So then as a result, what will happen, this object is starting to accelerate downward. So then when it going upward, so it will be going with a g deceleration. As it comes downward, it is coming down with a g acceleration. So that is what we were discussing. Okay, so then at the highest point, right? So now if it is released from this level, so then when it goes upward, when it reaches its highest point, so then the speed will become zero. So the initial speed there is 40, the final speed there will be zero. So then what will happen, it will starts to come down, right? So then the time taken to reach its maximum speed means you have to find the time taken for this motion, right? So then acceleration equals v minus u divided by t. So then we know the acceleration here is a deceleration, so therefore you have to use minus 10. So then final speed is 0, initial speed is 40 divided by t. So then you can cross multiply and divide by t, so then you can finally find the t as minus 40 divided by minus 10. So then answer is coming as 4 seconds. Is it understood? Right, so then the second part, uh, it says calculate the distance travel until reach maximum height. So that means simply this maximum height is what we are trying to find, right? To find that, we can use that equation, second equation we discussed, v squared equals u squared plus 2as at the highest point, right? So the final speed is 0, initial speed is 40 squared plus 2 into acceleration is minus 10 into the distance travel, right? So then this is 1600. 2 into 10 is 20, but it is minus into s. So then s is coming as, I think, 80 meters. So then 80 meters is the maximum height reached by the object. Calculate the distance, we can use v squared equals u squared plus 2as. So final speed at the maximum height is 0, initial speed is 40 plus 2 into acceleration is minus 10 into the distance is what we are trying to find. Then distance is coming as 80, I think, right? So check the answer. Right. So then these calculations are done without considering the air resistance, right? Now let's say how to discuss something, how to do a questions where the air resistance must be considered, right? So any how the object motion of the object is happening, right? Now keep in mind, so then air resistance is always acting opposite to the motion. If an object is falling down, so then the air resistance is acting upward, right? If the object is falling down, so then the air resistance is acting upward. If the object is moving upward, then the air resistance is acting opposite to the motion, right? Now if you want, you can say the air resistance as drag force as well, right? So it's no problem, it's the same thing. And also the normally the drag force, the word we use for both water and air resistances, it's not just for the air resistance, right? Now if you consider object like that, now let's say we have an object of a weight 10 newtons, right? So we have an object with the weight 10 newtons, right? And another thing I mentioned earlier, right, again I have to remind, I saw then the air resistance or the drag force is increasing if the speed of the object is also increasing. And the more the speed, so the more the air resistance. Now you can think about the walking and running in the water. So running in the water is difficult because when your speed is high, the water resistance will be high as well, right? Now we have an object of 10 newtons weight, right? Now this one will assume it is dropped from rest, right? So dropped from rest means you are holding it from a certain point and you are just releasing it. You are not throwing it downwards, just releasing your fingers. So then it is initial speed is zero. So then it is starting to fall down. So then we know initially at this point the air resistance acting on the object is zero, right? Why is that? Because the initial speed is zero, right? So then this is the initial situation. Speed is zero, air resistance is also zero. So then what will happen now on this object? So then the resultant force acting is equal to the 10 newton weight. Is it clear up to this point? Right. So when the object is released, now what happens? So then there is a resultant force. So then what happens? The object starts to accelerate. Why is it accelerating? Because of the 10 newton resultant force. We know according to Newton's second law, if there is a resultant force, object starts to accelerate. So now when this thing is accelerating, what happens? The speed is increasing from 0, 1, 2, 3, 4, like that. The speed is starting to increase. So when the speed increases, what will happen? Like we discussed earlier. So then the air resistance will be acting on the object now, and that air resistance will be acting. Air resistance, the value of the air resistance is also increasing, right? Now, for example, let's say we have situation like this. Now the weight does not change. So now what happens? There's a 1 newton. Let's say the air resistance is 1, right? So now air resistance is 1, is no longer 0. So then what is the resultant force of the object now? Yes, what is the resultant force? 10. No, not 10 now. Now we have two forces. 9. Yeah, good. So if one side 10 is there and the opposite direction 1 is there, so then 10 minus 1 is the resultant force. Now this is still a resultant force, it is less than the previous value. So then according to F equals ma equation, this object is still increasing the speed, it's still accelerating and the speed is increasing. So then air resistance is continue to increase. So then let's say air resistance is now 2 newtons, weight is still 10, right? So now air resistance is 2. Now what is the resultant force? 8 newtons. Yeah. So now the resultant force is 8, right? So then like that, so then this is accelerating, the speed is increasing like this. So it will go up to 9 newtons like this. So then the weight is 10 newtons. So then resultant force here is now 1 newtons. So then still increasing. Then what happens? At some point the speed, sorry, the air resistance is also equal to 10 newton. The weight is 10, the result, the air resistance is also 10. Now what is the resultant force? No, the air resultant force is 0. So we discussed earlier about the Newton's laws, right? So when an object starts to accelerate, right, so then this, because of the resultant force. So while accelerating, if the resultant force becomes 0, so when the moment that the resultant force becomes 0, it was already in motion. So then what will happen is object will be starting to move in a constant velocity or uniform velocity, that point onwards. Constant velocity, or we can say it's the constant speed. Understood? Yeah. So then, for a situation like this, when it reaches this constant speed, so then this air resistance is no longer increasing. The speed is also remaining same. So then the object will be moving in the constant velocity overall, right? So then this kind of speeds we give a special name. It's known as terminal speed or terminal velocity, right? So that is where the speed is no longer increasing, it stops increasing, right? So that speed we can call it as the terminal speed or the terminal velocity. Is it clear? So then this part is mentioned in the note as well, right? So then here it says their resistance, just like friction will oppose the motion of the object. Similar to air resistance, there will be a resistance from when an object moves through a liquid, and air resistance is proportional to the speed of the speed object. So if the speed increase, the air resistance will also increase. Uh, Consider an object dropped from rest. Initially, its weight will be the only force on the object and it is acting downwards. According to Newton's second law, the object will accelerate downward due to this force. When it is accelerating, speed increases, the air resistance also increasing. Right? So then now what will happen? The downward resultant force is weight minus the air resistance. When the air resistance is increasing, the resultant force is keep on increasing. Therefore the magnitude of the acceleration is also decreasing. Then there will be a point where the air resistance and the weight is equal, then the resultant will be zero, right? So that's what we discussed here also, right? So initially the weight, wherever we go, the weight is remaining same, but initially the air resistance is zero. So then the air resistance has increased from zero, 1 2 3 4 and up to 10. So then this is what we call as when the two forces are equal and opposite, so then there is no more resultant force, which will be which makes the object to move in a constant speed. That constant speed is what we call as the yeah, terminal speed, right? So here in the note, right? So there will be another last point. When the resultant is zero, the acceleration will be zero as well. From this moment onwards, the object will travel at a constant velocity known as terminal velocity, or we can say it is terminal speed, right? So then if you draw an object's motion of an object throughout this section, right? So whatever the motion the object is having, so then the shape of the graph will looks like a curve like this, right? Write that part and draw the shape of the graph. On this figure you can say the resultant force is decreasing. So initially it is 10 newton, 9 8 7 6 5 4 4 3 2 1, and it's coming to 0, right? So when the resultant force decreases, keep in mind, right? So we know the equation F equals ma. The mass of the object does not change, it is remaining same. So then if the if the resultant force decreases, the magnitude of the acceleration is also decreasing. Now, decreasing acceleration means, don't get it wrong, it is not a deceleration. So it is still an acceleration, but with negative, I mean, decreasing rate, right? Now it's like this. Now let's say we have an object. So initially starting from rest, the speed of object after each second will take it like 2 4 6 8. There's another object, so the speed of the object is going like this: 1 3 6 10. So then for another object, 0 starting from 0 5 9 12 11, 13, right? So you can see these are the speed of an object after each second, right? So you can see every time it is the speed is increasing, but by different amount, right? In the first second, speed increased by 2. So here also 2, here also increased by 2, here also increased by 2. So then how much speed increasing per second? We can say it as acceleration. So then this one has a constant acceleration. But in the second situation, the speed increased by 1, speed increased by 2, 3, and 4. So then how much speed increasing, that value is also increasing. So then that is what we call as an increasing acceleration. And here initially starts with 5, 4, 3, and here it is if it is, this is 13, then it is 1. So then 5, 4, 3, 1, right? Even though it does not follow the same trend, but still it is increasing the but it is the rate of the acceleration, or how much speed increases, that value is changing. So then this is the third situation is what happening in this previous case occasion, right? So then the resultant force decreases means the acceleration decreases. So that's what mentioned there in the note, right? Right, so this paragraph next to the figure. So when the air resistance increases, resultant forces keep on decreasing, therefore the magnitude of the acceleration decreases as well. Is it understood? Try while reading the question, right? So then we'll explain, right? So then until then, give it a try. Now, if you consider like a parachute, right? Now the skydiver, right? So as soon as he jumps off the plane, that's what will happen. Now his weight, let's say it's 500 newtons. The mass is 50 kilogram. The weight is about 500 newtons, right? So then the air resistance is acting. So then at some point, air resistance will be increased from 0 to 500. So when this air resistance is equal to the weight, so then he will be reaching the constant velocity. That is what the initial terminal velocity is. So then if you draw the velocity time graph for up to that point, this is the same graph we drew earlier. So it's going from there to there and reach a constant velocity, right? So now while falling, right, so let's say he opens up a parachute, right? So when the parachute is open, you can see the parachute has a much larger area compared to the person's body. So then what will happen? So then more air particles will be colliding with this parachute. So as a result, what will happen? There will be a large air resistance will be acting. So then let's say it is about 2000 newtons or something. So then 500 newtons is acting downwards. So then what happens now? There is a upward resultant force is there. The person was falling, but upward resultant force means the resultant force acting opposite to the motion. So that means he starts to decelerate, right? So when he starts to decelerate, what happens? The speed decreases. We discussed earlier, if the speed is decreasing, air resistance has to be decreasing again. So then the air resistance is decreasing 1900, 1800, 1500, 1000, like that, decreasing until it reach again 500. When it reaches 500 again, what happens? The forces are once again balanced. The resultant force is now 0. So then he will be moving in a constant velocity again. So that means until this point, from now this is the initial velocity from the graph. So as soon as he opens the parachute, what happens? The speed starts to decrease. So the speed decreases and it's again reaching a constant velocity. Now you can see this constant velocity, that means this is the terminal velocity, second terminal velocity. This is the second terminal velocity. Now this value is the first terminal velocity, right? So then the second terminal velocity will be less than the previous value. Is it understood? Can you understand what's happening there? So the skydiver jumps off a plane from rest. He starts explain why the acceleration of the skydiver decreases, right? You can say when he accelerates, speed increases, Therefore, upward air resistance increases. So then what happens when the upward air resistance increases means the resultant force, so then this is downward. Resultant force decreases. So as a result, what happens? The acceleration also decreases, right? So according to, you can say, if you want, you can mention according to F equals ma, right? Now this is like a 3 marks explanation question, right? So then these 3 points, the first 3 points are the ones that will give you those 3 marks. This kind of questions are there in the past papers, right? We will discuss some questions later, right? So then you can write something like that. Next one, explain how the skydiver reaches terminal velocity. So when they are increasing air resistance, it's equal to the weight. So no more air for resultant force will be there. So then he will be reaching constant velocity. Now, if this is a question in the paper, right? So it will be like 2 or 3 marks question. If it's a 1 or 2 mark question. So then air resistance is equal to the weight. So then this is actually 1 mark, right? So if it is a 1 mark, so then this is the point you get the 1 mark. So then this will be like a second point if it is given a second mark, right? But most probably this is like a 1 mark question normally. Now if the first part is also asked, then this is 1 mark question, or else now sometimes the question can be given combining both of these parts, right? So that skydiver jumps, how is he reaching the terminal velocity? In that kind of situation you have to explain everything, but according to this figure, the increasing air resistance and everything we have mentioned before, so therefore no need to mention here again. Next one, while falling the terminal velocity, he opens the parachute to explain why the skydiver starts to decelerate. So due to large area of the parachute, there will be a large air resistance. So then as a result, what happens? So then there's a resultant force acting upward opposite to the motion. So then this is why it's starting to decelerate. Now this is a 2 marks question. So then each point we wrote will give you 1 mark. Next one, skydiver reaches another terminal speed again, which is less than the previous terminal speed. Why? Can I write like this? So now the speed is decreasing from the previous terminal speed. So then when it keep on decreasing until the two forces are equal and opposite again. So then from that point onwards again another terminal speed. So then now this terminal speed is less because of the speed decreases from the starting point. So the next one, draw the velocity time graph for this motion, right? So then again you have to draw the same graph as the previous one. Right.